Right, morning everybody. I think we'll make a start. A few other people might join us in the next few minutes, but we're mostly here. So, what are we going to have a look at this week? So, let's just have a quick recap of what we did last week. So, I think we had a little bit of practice doing this first extrude example. So, that was the L-shaped block that we created using the extrude boss tool or the extrude boss base, and then we use the extrude cut tool to actually cut the circular hole there out of the block itself. And then I think, if I remember rightly, we did the revolve example as well. So we created this little spinning top part by using the revolve boss base to create the majority of the material, and then we use the revolved cut as well to cut away the actual groove here. So that would be the string groove in the feature tree. And obviously, as we were doing those examples, we were getting valuable practice in using the sketching tools that we're going to have to use for a lot of these features, and just building up our skills in that respect. So we were learning about adding relations into sketches, the fact that you should fully define your sketches, the fact that you, certainly for these features, you should always create a closed boundary in your sketch, and just the general skills that you're going to need going forward so that you can create most of the features in SolidWorks. So those sketching skills stand you in good stead with all features really. So this week, I think what we'll do is some more worked examples. So I'm going to work mostly from this PDF here. So this one that says week 10, extrudes and revolves. And it's not just the extrude and revolve tools that we're going to get a bit more practice in. We're going to use some different skills in the sketch portion of these extrudes and revolves. So it's worth doing them, even though we've kind of covered extrudes and revolves already. The way that we set some of these sketches up in this example is going to be new. So it's still worth doing. And then more than that, we get to use some other tools. So I'm just scrolling down quickly. The first part that we're going to tackle is this little L bracket. So you can see kind of the completed bracket in figure 7 there. And these figures, these numbered sort of screenshots, show how you build this part up using multiple features. So you can see we're sort of progressing along, and then we end up with this designed L bracket at the end. So a few things to note about this. The first thing is, what is this likely to be a part design of? Well, it looks, because of the thin wall that it's been constructed with, so you can see the back of it is kind of hollow, some thin walls have been left. I can pretty much safely assume that it's some form of molded part. So maybe it might be an injection molded plastic part, because that tends to be the method of design that you use for those sorts of parts. You make them out of thin pieces of material, thin walls, rather than solid blocks of material, which figure 4 is still kind of a solid block. And the reason that you might do that, just as a little aside, is that if you create injection molded parts and you leave quite thick wall sections, like figure 4 here, as the part cools, the outside obviously cools first because it's sort of more open to the surroundings, and the inside stays sort of partially molten for longer. And then as the inside cools, it tends to drag the outside surface inward. So you get a little impression, a little dimple, known as a sink mark. So that's why you try to thin out a lot of the walls like this. And the reason that I'm telling you this is we're going to use a new type of tool called a shell tool that takes a largely solid part, like this figure 4 here, and it kind of scoops the inside of it out. So in figure 5, the shell command has been applied to this solid part in figure 4, and two things have happened. So the rear face has been largely deleted, So the rear face here that I'm sort of indicating with the mouse has been deleted. The lower face has been deleted as well. And then the remaining geometry has been thinned down to I think this is a 2mm wall thickness. So you can do all of that just with a single feature, and it's called the shell feature. Another new feature that we're going to use in this example as well is we're going to use the fillet feature to put these rounded corners onto our part. So you can see initially the transition between these two faces here and these two faces is at 90 degrees. So you can see that face and that face are at 90 degrees to each other. There's a harsh transition line where they meet each other there, where there's a 90-degree transition. And the fillet tool just puts a nice radius on that transition. And again, so it's a new tool, and it sort of operates in a more simple manner than the extrudes and the revolve tools that we've been using so far. With the extrudes and the revolve tools and tools like them, you have to do a little bit of work first before you get your geometry. So you have to create a 2D sketch first. And then you get to create some geometry. These fillet tools and the shell tool are more what I'd term sort of a point and click. So you activate the tool and then you just click on some geometry and the tool does its thing. So arguably a little bit simpler to use. And then the final few steps here, we're just going to use a simple extruded cut to cut this hole through. But again, there's good practice to be had there, because the sketch that we're going to set up to define where that position is of that cut, we're going to use a few skills that we haven't really used yet in sketcher mode. And then the final one is just a simple extruded boss base tool here, just to add this strengthening rib in. But again, there's good practice to be had there. We're not just repeating what we've done before. There's a special case there where you don't have to create a closed boundary in your sketch. You can get the system to create something like a rib, like this, like a thin section rib, by not using a closed sketch. So that's sort of a special case that we'll have a look at. So I will get the first slide of this tutorial on my screen here. I'll keep referring back to this, so I'll just temporarily drag it away onto my other screen and I'll keep bringing it back as we need to reference it. The first sort of feature that we're going to make is going to be this upright block here. So figure 1 there is what we're aiming for, and I can already see from the sketch here that the origin point, so you can see it there, is at the bottom left, which on our block is going to end up there, at the bottom left, at the back of our block there. So that's what we're aiming for first. So I'll drop into SolidWorks. I've already got it booted up in the background on my machine. And then I think what we covered in some of the other sessions earlier in the week with the other groups was that different people were seeing different things when they logged into SolidWorks. So some people last week took my advice and pinned this menu so it was always visible. Other people have left it unpinned, so sometimes that menu's hidden like that. And then some people still had the splash screen visible like this, which you see when you boot SolidWorks up. But if you were to click outside of it, it disappears again. So by far the most foolproof method of initiating a new part file is to just click on this sheet of paper on the top menu bar, because I think the consensus was everybody can see that. That always stays there on the top menu bar, and it's the most foolproof method of initiating a new part. So we're going to click on that. So we'll click on that icon. Then we get this menu, and we're just going to double click on part because it's a part file that we're going to create here. So double click on part. You should then drop into the modeling interface, the part modeling interface. Again, we kind of touched on this last week, but it's worth kind of reiterating just before we get going. If you can't see the 3 base planes here, there's various reasons why that might be the case. The simplest one is to just try clicking on the eye icon at the top. Is the 2019-20 version fine? Someone is asking. Yep, that's fine. There aren't huge differences between the 1920 version and the 2021 version. So for these tutorials, it doesn't really matter. You can use either. You should be okay. So don't worry about that. So yeah, back to the planes. If you can't see them, try clicking on that eye icon and it may make them visible. If you still can't see them, you should be able to see them over here in the feature manager on the left, and maybe they've been set to hide. So you can see that I did a bulk select by using the shift key there on all the planes, and then that icon that pops up hides them, or if I do a bulk select again by holding shift, it then reverts to showing them. So maybe they've been hidden in the feature manager. So that's another option. The third option is this eye icon on the quick access toolbar, the heads up toolbar at the top. It's got a drop down menu at the side of it because it's got a little arrow pointing down, which means there's a sub menu underneath it. And there's options to hide planes in there as well. So with those three sort of different methods, you should be able to get your planes visible if they're not. So what are we going to do? I have already forgotten what we said, so let's bring the PDF back in. So we're going to create this block first. I'm interpreting this block as being the sort of front face of our part. Now, yeah, that's just an arbitrary call that I've made. I'm interpreting that as sort of facing outwards from the front of our sort of modeling window. So the reason I say that is when I now go to create my extrude boss base, which I'm about to do. So I'll click on the extrude boss base button at the top there. It asks me what plane I want to create the sketch on. I'm going to pick the front plane because I kind of made that decision that I was looking at the front of the part when I was looking at the front of this block. So click on the front plane. Your view should rotate round, so you're viewing it kind of at 90 degrees, which is called normal 2. And then I'm going to hold down control, hold down the middle button and just drag my view so the quarter of the screen that I'm about to sketch in, which is here, is kind of more central in my my window there. And then we're just going to create a simple rectangle. So I think we used the rectangle tool the other week. Maybe we did, maybe we didn't. But it's the corner rectangle version of the rectangle tool that I want. So if you haven't got that selected, again, there's a drop-down menu within this button. So if you click on the little arrow at the side, you get all the various rectangle tools that you can use. And it's the corner rectangle one that we want. And then the reason I picked that is that the first click or the first corner of this rectangle that I place, I want to lock it onto the origin point there. So you can see, as we covered last week, when I get near some piece of geometry, the system sort of offers me a relation to place on that point. And the one that it's offering me when I hover over the origin there, that little yellow icon that's visible, is a coincident relation, which is exactly what I want. I want this first point to be coincident with the origin. So when I get that icon, I just click. And then because this is the fourth time that I'm doing this tutorial this week, I'm pretty sure I remember the width and height of this rectangle. I think it's 40 millimeters wide and 60 millimeters tall. So you can see there's an XY readout underneath my pointer. So if I can try and hit somewhere about the correct scale, so it's about there, will do. That's near enough. And then click again just to draw the rectangle. And then I don't need the rectangle tool, so I'm going to press the escape key to get out of the rectangle tool. And then it's probably worth looking just at the relations that have been placed on this sketch by the system. So it's put some horizontal relations on the top and bottom lines. You can see those there, which are going to hold those lines to always be horizontal. It's put some vertical ones on the two upright lines there, and then it's put that coincident one on the point down there as well. So I think we'll add some dimensions in to hopefully fully define the sketch now, because you can see it's partially defined. This vertical edge here has been defined because one end of it is locked to the origin, so it can't move that vertical edge. It can, however, lengthen slightly, so its length hasn't been locked down, which is why the point on the end of it is still coloured in blue. And then again, you'd expect these two lines have got more degrees of freedom than these two. But we're going to correct that now. We're going to fully define this sketch using the Smart Dimension tool. So if you click on the Smart Dimension, click on the top horizontal edge, and then place your dimension with another click. And then we're just going to enter 40 into there for 40 mil. And then we'll do the same with this vertical edge here. So we could dimension either one of these vertical edges. It doesn't matter. They both do or achieve the same thing. So I'll click on that one, drop my dimension with a second click, and then enter 60 mil. So you don't have to type the millimeters. You just enter 60. And then I don't need the Smart Dimension tool, I don't think, so I'll hit Escape again. I'll do my quick check. Is it a closed boundary? Yeah, it is, because the system shaded it in this blue color. Again, if your systems are set up and they're not showing the shading, it may be because you've got this option unselected. So you can see that button is selected on my system, and I recommend that you leave it selected so that you get that visual clue that you've created a closed boundary. You don't have to investigate that as the user. The system kind of gives you a heads up and says you've created a closed boundary because it's shaded in. And then the second check, is it fully defined? There's an easy way to find out. You just have a look at the bottom menu bar there, the bottom readout, and it says fully defined. So yeah, we're happy with the sketch. So we're going to exit the sketch by clicking on the blue icon at the top right of the graphics window. So that icon there, OK is the sketch. Then we get a preview of what the extrude's going to look like if we want to rotate around a little bit and just inspect that. Whereas the front plane relative to the extrusion, yeah, it seems to be in the right position. It's at the back of the extrusion, which is what I said. This reference that we were working from, I said that back corner there is where I'm deeming the origin of this part to be, looking at the reference material that we're working from there. So yeah, that's the decision I've made. So is that correct? Yeah, it looks like it's correct. It's at the back left corner when you're viewing it from the front here. Obviously, it's probably worth just reiterating some of the options that you get in the extrude before we OK this thing. So we could flip it in the opposite direction, this extrude, if we needed to. So there's the reverse direction icon. You can have a little play with that and see what it does. It goes in the other direction. What else did we play with the other? Yeah, I think we'll set the depth and we'll move on to the next extrusion, because we can have a little play around with those options in that one as well. So the depth should be 5 mil, not 10 mil. So I just over-typed the number there. And then we can OK the extrusion because we're happy with it. So the green tick icon OKs that. Again, have a quick look at it. Yeah, it all seems all right. The plane's still where we left it. Yeah, it's added that feature into our feature manager tree there. It's named it. It's hidden the sketch that created it, but the sketch is still available if we need it. It's just filed it away inside the actual feature itself. And it's set its visibility to hidden. So if we want to bring it back and make it visible again, we can. Just in the same way that we did with the planes, you just click on it in the feature tree and use that eye to either hide it or make it visible again. So yeah, let's move on to the next feature. So if I just orient my screen so it's more or less like the tutorial that we're following. So that's what we've created so far. This block is what we're going to create next. So this is a second extrude, and if we kind of scroll through the tutorial a little bit, so we've done this piece, we've done this section here, we've extruded it by 5 mil. Now it's advising that we create a sketch on the front face of our part. So that would be that face there. So that face, create a sketch on there and extrude outwards by 50mm once you've created that sketch. So that we're going to do that next. So I'm going to create an extrude. So I'm going to click the extrude icon. It's going to ask me what face or what plane do I want to create my sketch on. I've already said this front face of the block that I've just created. Then it doesn't auto rotate my view, so I'm viewing that face normal to the face. So I think I showed this group last week how to customize their head-up display here to add buttons onto it. So you can see I've got the normal to button there. If you didn't do that when I kind of showed you last week, it's also available in this drop down here at the side of view orientation. So you can see the button is available in there as well. But yeah, I recommend, if you haven't customized that, watch back the recording from the other week, and yeah, I'll tell you how to do that. So we're going to create this sketch. It's just going to be a corner-to-corner rectangle again. So if we get that tool again, that's the tool that we're using because we want to lock one corner down here onto this point, which happens to be right over the top of the origin. You can kind of see the origin there with two little red arrows indicating Y and X direction away from the origin. So yeah, I want to lock one point so it's coincident with that point there. And then I want to lock the other corner of the rectangle onto that vertical edge of the block. So anywhere along there will be fine because we're going to add a dimension in a minute to set the height of this. But yeah, I want to make sure it's locked onto that vertical edge, which it is. When I place it there, I do this second click. You can see it's put a coincident relation right there. Then I don't need the rectangle tool again, so we'll hit escape. I'm going to get the smart dimension tool, and I'm just going to dimension the height of this. And I think it's 10mm. In fact, I'm sure it is. So you can click on that vertical edge, or you could click on the bottom edge and then the top edge, and it'll give you the distance between those two items. And either way is valid for this. It's just showing you a different way that the Smart Dimension tool behaves. So if you click on two things, it tends to give you the distance between them. So click there to drop the dimension and then enter the value that I want, which is 10mm in this instance. And then we'll do our checks again. Is it a closed boundary? It appears to be. It's been shaded in. Is it a fully defined sketch? Yes, it is. Fully defined at the bottom there on the toolbar. So we can OK the sketch. OK that sketch. We'll get a preview, but it'll be difficult to see what's going on because we've activated the normal to view direction. And the system on the second feature and all the subsequent features doesn't auto-rotate your view. Not by default, anyway. So we'll manually rotate around to try and appreciate what's happening with that extrude. And the depth of this, I believe it's 50mm, if I remember rightly. Yeah, 50mm. But that 50mm is measured out from the sketching plane. So the sketching plane is this front face of our first feature. So from that edge there, all the way along this new block out to that edge there is 50mm. And the reason I say that is, so let's just set that just momentarily. Let's go in, set the 50mm. So 50 in that box, press enter. The preview will then update. Someone asked the question in one of the earlier sessions, surely you just get the same output if you extrude that block in this direction as you get if you extrude it in that direction. But hopefully you can tell why that isn't the case. And it isn't the case because in this direction, even though it's going 50mm from the sketch plane, it has to pass through this 5mm block first. So you end up with a sort of bottom leg of this L shape, this capital L, being 45mm long, because it has to get through that 5mm block first. So yeah, it's worth just sort of appreciating that. It seemed obvious, but it's a common sort of mistake that you can make as you learn in SolidWorks. So yeah, the distance is measured from the plane or the surface that the sketch has been created on. So you get two different outputs depending on which direction. And we want it in this direction because we want the resulting leg of the L, if you want to call it that, to be 50mm along its top surface. So we're happy with that. We can click on OK to OK the feature. And then if we have a quick look at where we are, so we created that feature. Now we're going to go in and create these fillets that we were talking about. That essentially, as I said earlier, it takes two faces that meet each other at an edge, and it smooths the transition from one face to the other face. And the way that it smooths them normally is that it just adds in a little arc. So it adds in a part of a cylinder, I suppose. And you can set the radius of that arc. So you can see when we come to set this up, there's the radius value, 5mm. So if this is a portion of a cylinder that it's adding, it's a 5mm radius cylinder. So we'll do that now. So if you look on the feature toolbar at the top and search around a bit, you can see there's a fillet option there. So there's the fillet button. And you can click on that and then start selecting edges. And that's a valid way of doing it. But by far the quickest way of activating the fillet tool is just to click on an edge in your model. So if you click on an edge, any edge, of the icons that pop up, you can see the fillet one's already there. So that's a little time saver that they've sort of inserted into SolidWorks over the years, just so that the distance traveled by your mouse pointer by you just gets minimized. So it tends to happen in a lot of cases when we're adding our own user relations into sketches. It does a similar thing. So if you select an edge and a point in a sketch, it gives you some quick access icons to do with the relations that you can add to those two things that you've clicked on. So yeah, you may as well take advantage, is the thing to take away. You may as well take advantage of all the time-saving tools that they've put into SolidWorks. So click on that edge, click on the fillet icon to add a fillet to the edge. You get a little yellow preview again of what the scale of that fillet actually looks like in position. And then, because of the way that this tool works, this fillet feature tool, you can click on multiple edges. So we're going to go around and select all these external corners on our part. So you just hover over an edge till you got the edge selected, click, and then rotate your view a little bit so you can see the next one, click again. And if you're not seeing the full preview on all four edges like that, it's probably because you've got this option selected. So you can see you can have a full preview like I've got of all the edges, or you can have a partial preview, or you can even have no preview at all. But yeah, I prefer to leave that set to full preview. The reason that you might have it on partial is that in very, very complicated models where you select lots of edges, the preview itself can take quite a while to calculate by the CPU. So they leave it off just as a safety thing, or they leave it, I think, on a default install set to partial. But every time I come in, I tend to set it to full. And then the last step here, so the last few things to say is, you don't just have to select edges with it. You can select an entire face. So let's rotate around the back of the part here and click on this big face on the bottom. And you can see it applies a fillet to all edges that run away from that face, if you like. So you can see by the preview there. And then if I want to deselect some geometry, I can just click on the geometry that I don't want anymore, like that, and it should deselect it. Or if you look over to the left here in this box that we're slowly populating with edges, you can see the face that I've selected there. And if I right click on it, I can select delete. So either way, to get rid of edges or faces that you don't want. So you can see I can delete anything out of there one by one. Or I could clear the entire box if I wanted. So yeah, that's how the fillet tool behaves, and it'll just apply the same radius to all the edges that you put in that box. And in our case, we want to set these edges to 5mm, or these radiuses to 5mm. So lower down there, there's a numerical entry box, and if you just type 5mm in, press enter, the preview will update, and that looks good, and then we'll just OK that feature by clicking on the green tick. So we put that one in. So the next bit is to put a second fillet feature in. So if I scroll down a little bit, you can see a second one has been added to this internal edge. And I was sort of scratching my head thinking, why is the person that's written this tutorial bothered to add this edge in as its own separate feature? Why don't they just click on it when they're putting these ones on the outside? And the logic that I sort of came to the conclusion of was that within this design for this bracket, these edge ones on the outside of the part kind of represent a different bit of the design, if you like. And it might be nice in the future to allow someone to be able to vary the radius of curvature of this one that we're about to add separately to these ones. So even though they happen to be set to the same value currently, which is 5mm, we're just going to add a 5mm fillet there. In terms of the design, they represent two different things. This one's been placed there to try and minimize stress concentrations on that harsh edge there. So if it wasn't there, this part would be prone to failure along that edge because all the stress gets concentrated down into these sharp corners. So adding this fillet in there kind of dissipates a little bit of that stress and corrects that problem slightly. So yeah, this has a different function to these ones in terms of this actual part, this design. So that's why it might be good to separate them into two different features just for ease of modification later on. So we know how to add them now. So I'll just click on that edge, click on the fillet button. I should get a preview. It should be the right radius curvature. If it wasn't, I could overtype there. And that's it. We don't really need to bother about changing too much there. We can just click on OK. So you can see, as I was saying earlier, that fillet tool and the shell tool a bit later, they're more what I'd term them as just point and click or point and shoot tools. They don't require the same level of work that these feature tools that require a sketch require of the user. They're more sort of just click on some geometry and they will modify it for you. So what are we going to do next? Is it the shell command? Yes, I believe it is. So this is what we're going to do next. We're going to apply that shell command that I was talking about earlier. And again, this is one of these sort of point and click tools. You essentially just have two inputs here. You tell the system what faces you'd like to remove, and then you tell the system how thick you'd like the walls to be on the geometry that you're going to leave behind once you've removed those two faces. So you can see we're looking at the back of the part, or what I'd consider the back of the part there, and the lower face of the part. Those two faces have been highlighted in blue, which means those are the ones that are going to get removed. You can see them there in the entry box. And again, these entry boxes, when you initiate a feature, they tend to glow blue when they're waiting for some input from the user. So they tend to glow blue when they're waiting for you to click on some geometry to put in there. But we'll talk about that in a sec when we actually get the tool running. And then you can see the 2mm thickness has been just entered in that entry box there. So let's do that. There's the shell command. Again, if you're struggling to remember where commands are, it's pretty easy. You just hover over these things. And if you can't get the gist of what the command does or what the feature does from the actual icon itself, because most of these icons are quite self-explanatory, then you can just hover over them and you get the name and you get a big long description of what that tool actually does. So So you can see hollows out the part, leaving open faces, and so on and so on. So that is the shell command. As I've already said, when the system's waiting for some input, it tends to highlight the input box in blue. And if you hover over it again, you get a little tooltip kind of telling you what it's waiting for. So faces to remove, which is going to be that back one and that one there. And again, if you pick one of these in error, you can always click on it a second time and get rid of it. So those are the ones that we want to get rid of. The wall thickness we want to set as 2 mil from the geometry that's going to be left behind after this feature. And then I always like to have a little preview of that like we get in the other feature tools, but the preview tends to remain off by default in here. So you can see that show preview box is unticked. So we're going to tick it just so that we get a preview of it. Yeah, that looks good. And I can't spot any problems. So what can happen, let's say I bump this value up to some huge value, 20 mil thick faces or something like that. You can see it's not even giving me a preview. And the reason for that is you can't have a 20 mil thick outer wall here because the part isn't big enough to allow that. So I don't even get a preview. So the preview can kind of tell you whether the feature itself is going to fail or whether it's a valid set of inputs. So a 2 mil thick wall and removing those two faces is valid because I get a preview there. So click on OK, and then it does the shell feature. And if we just have a look at what it's done, so you could imagine a method that I could duplicate what the shell feature has just done. So let's just temporarily undo the shell feature like that. So that's as the part looked before it. So you could imagine I could create an extruded cut and I could sketch on this face here and sort of extrude down into this part slightly, leaving a 2 mil wall all the way around. But that would be a lot of work. And then I could do something similar on this face as well and create an extruded cut and then try and replicate that, that fillet feature somehow on the inside as well. But obviously, that's a lot of work for the user to achieve that then. So they've put the shell tool in just to ease your workload, basically, to automate these steps of scooping out this amount of material. And the reason they put it in is that lots of people use SolidWorks to design molded parts that are going to need a thin wall. So there was a demand, so they put the feature in. But it's doing some quite complicated maths and geometry in the background for you. So yeah, it's quite a useful tool. So let's have a look. What are we going to do next? We're going to create the cut through. So you can see there, we've got that little square sketch. And then when it cuts through, you can see what it's doing there. So we'll just analyze what's going on a little bit here. So we're going to cut through the thinner of the two legs of RL. So you can see that's the 10 mil thick leg, and this is the 5 mil. And it appears as if the sketch has either been created on the back face here, or more likely the front plane, which the two are coincident with each other. You can see that. I'm viewing them side on, and you can see that that remaining back face there and that front plane occupy the same sort of plane in space. So it's likely that we're going to create this square sketch on that front plane, and we're going to extrude through the part as shown there. And we're going to use the through all option in this instance for this extruded cut. We sort of played around with some of the options the other week. I think we obviously did some blind extrudes, but we also did I think we did a through to next, or through to a specific surface that we clicked on. But this one is a through all, which basically means this extruded cut will just keep traveling and traveling and traveling onwards into infinity, essentially, and anything that gets in its way gets cut. So yeah, it's quite a crude method of setting up the end condition of this cut, but it will work in this example. It achieves what we need it to. So yeah, let's get going and get that extrude cut set up. So if you click on extrude cut on the features toolbar at the top, click on the plane, so it'll be the front plane I've already said. Then you want to rotate your view so you're normal to that plane, like that. And then what we're going to do, we're going to create a rectangle first, and we're not going to use the corner to corner, because ultimately what we want to do is have a square which is locked to the center of this face. So this face that we're looking at here, that face there, we want our square, as it will be, because a square is just kind of a special case rectangle that happens to have equal height and width. We want some method of locking its center point to the center of this face horizontally. So we need a rectangle initially that has a center point. So we don't want the corner to corner rectangle, we want the center point rectangle. So it's there, center rectangle. And with this one, if you want to hover over it a bit before you come to use it, you can see first click places the center, and then you drag outwards, and the second click places one of the corners. So I'm just going to quickly drop that in my sketch there. I don't have to make sure it's a square at this point. I can sketch it like that. So drop that into the sketch. Hit escape to get out of the tool, because I don't need the tool anymore. Inspect what the system has given me. So it's given me 4 solid edges, and then it's given me these 2 dashed lines that run diagonal from corner to corner. Now the dashed lines are known as construction geometry. And basically what they are, they're there to perform a job in the sketch, but the system doesn't automatically create any solid geometry from them. So it will ignore them when it comes to create the extrude cut. It won't try and cut in a strange sort of triangular shape. It will just ignore these dotted lines. So all construction geometry is there either for the user or to hold another piece of geometry in position. So that's why we've got these 2 diagonal lines. Now we're going to create our own piece of construction geometry to allow us to hold this rectangle as it is now in the center of this face. So central horizontally is what I mean. So in this aspect, I want it held permanently in the center there. And the way I'm going to achieve that is I'm going to get the line tool initially. So line tool to sketch a line. I'm going to lock one end of the line probably to the center mark here. So if I hover over the center point of this rectangle till I get the constraint visible there in yellow, click. So I've locked one end of the line onto there, and then I'm going to lock the other end of the line to the midpoint of this edge up here. So you can see as I get near the midpoint of that edge, the exact center becomes visible as a little yellow center dot, which means I can lock the end of my line onto that. So hover over it till I get that constraint visible in yellow, and then click again. And then I don't need the line tool, so I'm going to press escape to get out the line tool. So you can see I've now got a line which is fixed to both the center point of my rectangle sketch and the midpoint of that edge up there, which we're only one step away from locking this in the middle now. And that step is to just select my line there. So click on the line and set it to be always vertical. So like that, make vertical. So now you can see if I try and drag this off center, I can't. The only thing I can do is drag it up and down. And obviously its scale in terms of its width and height are still open to movement. So they're underdefined as well. But it's been locked to the center. So the last little step of that bit of setting this sketch up is to click on our line that we created there, because it's a solid line. It's not construction geometry at the moment. So it's ruining our solid boundary here. So we want to a closed boundary, and we haven't got one. We've got this line cutting in to the center of it. So if you click on the line, and again, the quick access icons that pop up are specific to what you've clicked on. And this one here that looks like a solid line transitioning into a dotted line is the make construction one. And then if at any point you want to convert some construction geometry back into a solid line again, you just click on it and press the same icon again, and it'll turn back into a solid. So yeah, that's the quick access way of doing it. There is also, if you're unlucky enough to wiggle your mouse button around and that quick access menu disappears, there's an option over on the left hand side there to switch construction on or off for any given line. So you can use that as well. But yeah, a lot easier in all these cases if you can use the quick access icons that pop up. So it's a lot quicker way to work. So there's a few things just to finish off here. One is to make this rectangle into a square. So that's pretty easy. All we're going to do is put an equal relation on one of the horizontal edges and one of the vertical edges. Doesn't matter which two you pick, as long as you pick one horizontal and one vertical and set them to always be equal to each other. So I'm going to do that now. So click on that line, hold down Control, click on that line, and then look for the equal sign there, which represents an equal length relation. So click on that. Now it's always held as a square. So you can see that. You can try and drag one of the corners and the width and height change simultaneously. So we're nearly there. We just have to define the size of the square. So we'll get the Smart Dimension tool out now. Click on that. And because it's held as a square, we can dimension any one of the four edges. It doesn't matter. So I'm going to pick this one here. Place my dimension. Tell the system it wants to be 8 mil. So the square size is now set. And then the last little bit is just to set the square's distance down from the top edge of my part. So if I click on the top edge of the part and then click on the center mark of the square, and then I think that should be 25, yes, 25 mil, like that. And then that should be complete. So we'll do our checks. It doesn't look like it's been shaded in. So just let me hit escape to get out of the Smart Dimension tool. It doesn't look like it's shaded in, and that's because we're viewing it from the wrong direction. So this sketch is actually behind our part there. So you can see that as I rotate around. And while the sketch lines themselves are visible through the part, the actual shading action isn't. So yeah. So if you rotate around, you can see it has been shaded in. And it's fully defined. So it says fully defined down there. So we're happy. We can OK that sketch. We get our preview. And then lo and behold, the system's picked the wrong direction. So there you go. It's trying to extrude cut out into empty space in this direction. So the first thing we're going to do is flip the direction, which we should know how to do. It's that double arrow sort of button there under the word direction 1. So it's going in the right direction now. And I've already said we're going to pick the through all option. But again, I think I illustrated this last week, why in a lot of cases it's counterproductive to give these extrude cuts a number. And in this case, I would say that's the case. So don't do this. Just pause where you are, and I'll come back to where you are. I'm just illustrating why it might be a bad idea to give this particular cut a fixed number. So let's say we gave it a fixed number of, let's say, 20 mil. And then we okayed that feature. And it would achieve what we needed it to achieve. So it's cut all the way through. So we're happy. But then someone in our design department says the L brackets that we produce, we've made a decision that this 5 mil wall needs to be much, much thicker for the purposes that we need them. So let's bump this 5 mil wall up to 30 mil. And then lo and behold, our cut doesn't work anymore. So you can see it's less adaptable to change. if you set these extrude cuts, which you intend to always pass through the part, to a set depth, it's not very adaptable to change in the future. So other bits of the part may get changed, and your extrude cut that you intend to pass all the way through the part doesn't go deep enough anymore. So at that point, you could go back in and change the depth of the extruded cut. But that's a lot of unnecessary work when you could have just set the extruded cut to one of the sort of logic-based options. So that would be all these ones. Through all is a logic-based option. Up to next is a logic-based option. Up to surface is kind of a logic-based option as well. So put some logical termination to the cut, either when it meets another surface or through everything. Yeah, these are more robust ways of creating a cut that always passes through your entire part. But in some cases, you will want to give a cut a depth. I can think of instances whereby I've drilled holes into a block, thinking I'm going to thread these holes, I'm going to tap them and put a thread into them, and I've not wanted to pass all the way through the block. I wanted to stop. So then you would give it an actual depth figure. So yeah, just a little bit of thought about how the design might change in the future, and is this the most robust method to model this feature. But what I'll do, I'll drop back into that feature. So for those of you, I think we covered this last week, but a lot of the sessions, I can't really remember whether I said it to one group or whether I said it to the other group, because, as I say, there's 4 groups in this particular module. But if you want to get back into a feature, if you've okayed a feature and it's in the feature tree and you want to go back in and change something about it, you just click on the feature over here, so in the design manager. So I'll do that again. Click on the feature. Of the icons that pop up, it's that first one, edit feature. And it will take you back into the dialog where you got to when you were defining the feature itself. So I want to change that from blind to through all in this example, and then OK the feature again. And likewise, if I want to go all the way back into a sketch that is within a feature, I could just click on the feature icon again, and that second option is edit sketch. And then I'm back in the sketch and I can make changes. I can add more lines in if I need to add some lines in, or do whatever I need to do. I'm essentially back at the sketcher point again. And then when I OK that, whatever changes I've made will get applied to that feature that's above the sketch. So the sketch is essentially, to use the right terminology, the sketch is a child feature of the cut extrude. So yeah, it's referred to as parent-child relationship. So let's move on to what are we doing next. So we're going to create this rib round the back of our part. So we're going to be viewing the part from this sort of perspective, and we're going to create a 2mm thick piece of material that runs across here. So the thought behind that in this design would probably be, maybe there's some weakness in this part. Maybe it gets exposed to some kind of stress where it gets a force pushing on this side and it gets a opposing force pushing on that side maybe, and it needs this strengthening rib in between. That might be a sort of common reason that you'd put extra material in rib form. And we're just going to use the extruded boss base to create this rib. So we're going to sketch. Either we could sketch on the front plane there, but just for a little bit of variety, I think we'll pick this back face as our sketch face. And the reason I say that is it sort of illustrates the point that even though our sketch, so here's our sketch as it will be, even though our sketch is not actually on that face as such, because that face is just a thin 2mm boundary that runs around the outside, the system doesn't care. As long as the face that you pick is perfectly flat, the system is willing to regard it as infinitely large. It just regards it as another plane, just like all the base planes like this front plane and this right plane and this top plane. As long as the face that you pick is perfectly flat and planar, the system is willing to regard it as going in all directions infinitely. So it's infinitely large. So that's why you can sketch in the middle here, even though that face is a very thin 2mm face. So it just regards it as a plane, essentially. So extruded boss base, we're going to do. So I've selected that from the features toolbar again. It's asking me what face I want to sketch on or what plane I want to sketch on. I'm going to pick that back face. I've already said that. And again, it doesn't rotate my view, but I can do that myself. I think let's illustrate that you can sketch without rotating your view normal to the face. Let's sketch in an isometric view like this. So I'm going to get the line tool. Point-to-point line is what this is going to be. I'm going to let one end lock itself to this vertical edge here. So you can see that vertical edge is highlighting when I hover over it. And I'm getting that coincident icon. So I'm going to click there. Then this is where it becomes a bit difficult. If you are sketching from an isometric view, like we are doing now, sort of 3D view point, even though the system's there is giving me that horizontal relation icon, so it's telling me, it's saying the line is currently horizontal. It's hard to tell that for sure from the view. It may be slightly deceptive, and I may think, oh, well, that looks more or less horizontal. Why is it not? So yeah, that's one of the difficulties when you're sketching from a 3D sort of perspective. But we'll persevere. So yeah, I want to lock this line to horizontal, and I want to lock the second point, so the other end of the line that I'm about to place, to that edge. So when I get the coincident icon in yellow and the horizontal icon in yellow, then I'm going to click, and then I don't need the line tool anymore, so I can press escape. And then I might investigate how is this line free to move. So you can see if I just click and drag on one of the ends, it is attached to that edge. And again, by that edge, I mean the system regards that edge now, because it's perfectly straight, as extending off into infinity. So you can see I can drag beyond where the edge is. In that sense, the edge just goes on and on and on. But I can't drag this point off the actual edge itself. It's always coincident with it. And same with the other end. I can't get that point to come away from the edge, but it will extend off into infinity like that. So the coincident relation means what you're seeing here. So I could put a coincident relation between that point and that edge and still have this line all this distance away from where the edge ends. So yeah, you just got to sort of grasp that as long as an edge is straight and as long as a face is flat, the system regards them as infinitely long or infinitely large. So there's one dimension that I want to put on here, and it's that one there. So it's 12mm down from the top of the part. So get the smart dimension, click on the top edge of the part, click on the edge, the line, sorry, that I've just created, place the dimension with another click, and then 12mm, like that. So just before we exit this sketch, so this sketch is fully defined, we can check that, but crucially, we have not fulfilled the other thing that we said we always should, which is that it's not a closed boundary. It's just a single edge. Now, what we're going to do is we're going to look at this special case of there's certain instances where you don't have to create a closed boundary, but we're going to look at how the system then handles that when we go into the extrude dialog next. So let's say we're happy with this sketch, and we'll OK the sketch. So click on OK. The first thing that the system does is it reminds us that we haven't created a closed boundary of edges. And basically what it's saying here is it's saying, do you want me to close this sketch up for you by adding some more lines in? And in this instance, we don't want that. So we're going to answer no. But it knew that we'd violated the rule that we set for ourselves earlier on by saying we always have to create a closed boundary. It too has a problem with that, and it's offering to fix that problem. But we don't want that help. We're going to say no. We want to persevere with this open sketch. No. So then what it does is it comes up with a second solution for us that it's activated now that we're going to talk about. So what it's done, you can kind of see what it's done there if you rotate around a little bit. It's taken our edge, our single line in this instance, and it's added material to a thickness that is specified down here. So it's 10 mil. So it's added 10 mils worth of material away from that edge in a certain direction. So the way I'm looking at it is sort of to the right or down towards the bottom of our part. So that's its second solution that it comes up with. It says, you haven't created a closed boundary, so I can't fill in the boundary with solid material because you haven't created one. So my second solution, other than modifying the sketch for you, is to just add some material to one side of the line that you've supplied me with. And what that's called is, it's turned it into a thin feature. So you can see, it's pre-selected, this tick box here, and we cannot unselect it, so it's grayed it out once it's selected it, and it's switched on thin feature, which is a sub sort of category of a boss extrude. It's a special type of boss extrude. So it's done that for us because it couldn't solve the problem any other way. We refused its help in terms of making a closed boundary sketch, and so that was its last attempt at creating a valid extrude for us. Now, in our case, that's exactly what we want. So the thin feature is very useful when you're designing parts like this bracket that have to have these thin walls in them. So if you're molding things and you have to thin the walls right down to accommodate the molding technology that you're using, so plastic injection molding is a great example, then using thin features is quite useful. So yeah, it's a time saver because we could have achieved this. We could have sketched out a rectangle that was 10 mil thick, but we've essentially saved ourselves some time just by we create a line and it switches this on for us. So that's kind of a time saver. So I've already said this thickness of this thin feature we need to set at 2 mil because it's going to match the wall thickness of our major walls around the outside. So I'm going to set that to 2 mil for the thin feature. And then if we have a look at our reference images again that we're working through, this one, hopefully you can tell, the line sketch has been sandwiched in the middle of it. So you can see there, that black line sketch, that's a 2 mil thick rib, and 1 mil of material's been added at one side of the sketch and 1 mil of material's been added at the other. So we're going to set that option. So rather than adding it in a single direction, one direction there, we'll have a look at the other options. There's a mid-plane, just like there is up here. So for the major extrude direction, which currently is wrong in my setup here, it's going outwards from the part. So we played around with mid-plane up there, but you can also set mid-plane as an option down here for the thin value that it's adding. And then if we zoom in, you can see the sketch is now sandwiched in the middle, which is what we want. So one last thing, I want to change the direction of the major extrude direction that I have set here. It's going upwards. I want it to go downwards towards the part. So we know how to do that. That's just reverse direction up there that we've used before. So now it's going in the right direction, but it's going too far. It's going all the way down through my part. And again, rather than just set this as a blind value that will remain static, even if the rest of the part changes in size, it would be good to put some logic behind this. So I'm going to change this from blind to up to next would work in this instance. So it would travel through empty space until it hits something. So the next there is the next thing that it hits. So that would work. You can see that that's working. But in this example, we're encouraged to play with some of the other options, and one of which is up to a surface. And what this allows you to do, if we set that, is you can click on a specific surface within your model and it will travel until it gets to that specific surface. So it's this surface here that we're going to click on. So that achieves exactly the same thing as up to next in this instance, but it's good practice for us. Up to surface requires a little bit of user input, and you can pick a specific face. So that's set up. So we're going to OK it. And then one last thing. So I try and equalize all these sessions in terms of the little bits of tips and things that I give to people, but I often forget. So it's just occurred to me that I sort of highlighted to at least two of the other groups, I think, that the behavior of features that touch each other, so this thin that we've just created was touching the existing geometry, it unifies them into a solid block of material. So you can see there's no join there at all. There's no visible join, and that's because the system now regards all of this as a single block of material. Doesn't see any difference in terms of keeping track of the join that defines this feature and that feature. It's just one big piece of material. Sorry for interrupting. If the class recorded, can I leave? Because yeah, that's okay. You can dip in and out of these as you need to. And yeah, there'll be a recording of this one, so you can probably dip back in and see what we've been doing. Okay. So yeah, the system unifies everything into a solid whole. And to give it its correct name, there is a single solid body in this part. And again, because your setups are slightly different to mine, your software installation, that is slightly different to mine, you may not be seeing this solid bodies folder here. But I've set that to always be visible. On your systems, I think that would only become visible if you were to create a totally separate solid body over here. So again, don't follow what I'm doing here, but just to give you an example, if I was to create a cylinder that sort of sat out on its own way over here in free space and then gave it an extrude depth, I have then created two solid bodies in this part. So that cylinder wasn't touching my existing geometry, so it's been added as a second solid body. And if you were to do that, the solid bodies folder should then appear in your installations, and you can see you've essentially created what could be regarded as an assembly, although technically it's not. So yeah, the default behavior is if things touch each other, they get welded together, if you want to think of it like that. And then another skill. So just as we're digressing here, it's good to know how to delete features, which is reasonably easy. So this feature here, I want to delete it. So I just select it in the feature manager there, hit the delete key. I then get a little confirmation. Do you want to delete it? Yes, I do. And then the sketch that went into creating it has now been orphaned. So the sketch is there in the feature tree just as a sketch now. And if I wanted to reuse that sketch, I could just pre-select it and say, actually, can I create an extrude from that? Yes, you can. So you can create extrudes from existing sketches if you need to. That's a possibility. But if I want to delete that as well, just click on it again and hit the delete key, and I get the confirmation. Do you want to delete this sketch? Yep, I do. So yeah, so that's that one. Kind of complete now, I believe. I don't think there's any other steps. Yeah, so we've got the finished part. And then if you want to save that, obviously just checking that people know how to save things in it is always a good idea. Again, the most foolproof method to save these, that everyone should be able to see the same icon on their installation, is just that old school sort of floppy disk looking icon at the top. That is save. So if you just click on that, what the system will do is it will navigate to a folder on your machine, and then if you want to put it in a different folder, you can do, and then just give it a part name at the bottom, a suitable part name, and just hit save, and then you've saved it. So I'm not going to bother because I don't really want a copy of that, but you might want to get back into that at some point. If you can't remember, oh, hang a minute, I don't remember how we did such and such, you can load this back up and you can go back into these features and sort of interrogate your own work to try and figure out, how did we set that up? How did we do that? So it's quite a good reference for you to sort of go back if there's something that you don't quite remember. But I'm just going to shut that down So if you want to close a part file down, it's just that little X, as you would expect, at the top of the graphics window. And then mine's giving me a warning just saying, you haven't saved this document. Do you want to save it? And I don't. And then I'm back to where I came in. So I'm just going to ask a quick yes, no. So did everyone find that okay? Could everybody follow it? Or did people run into problems? So the question is, was everybody okay with that bit of the tutorial? Did it leave them behind? So just give me a yes if that's all achievable by everyone. Oh dear, I'm only getting one person. How many people are still here? 8 people, including me. Yes, we're getting some yeses, so that's good news. That's what I want to hear. So we've got around about 45 minutes, I think. I think we'll get through this next example. So let's have a little talk about it before we begin. So the next example is a revolve boss base, which again, we kind of covered the broad outline of how you create a revolve feature or a revolve boss base. And this is a little bit of an intro if you're not familiar with them, which we are now. They tend to be a sketch profile that then gets spun or revolved around the center axis. And it's just showing here you can revolve entirely round 360 degrees, or you can do a partial revolve. So this one's just gone through 90 and this one's gone through 180. So we get kind of the broad concept of it. Now, this one's an interesting one. I've been doing this all week, this pulley. So this is a design for a pulley. You can see it in cross-section there. It's just kind of being sliced through. It's a single feature part, or certainly the way that we're going to do it initially. It's a single feature part. So it's just a single revolve in a part that creates the entire part geometry. We'll talk about, after we've done it this way, we'll talk about why it might be good to do it as a multi-feature part as well. But it's essentially this sketch that you're looking at here. So this is a screenshot. And just to look at it initially, you think, well, right, that's not that complicated. That sketch is reasonably easy to understand. But the problem comes if you were to create this sketch freehand by use of the line tool, which is what we're going to do. If you sketch the entirety of it freehand first, the chances of it being the wrong size and the wrong scale is very, very high. The chances of you hitting more or less all these values almost perfectly freehand is almost zero. You're not going to do it. So then the problem becomes when you start applying these dimensions to the sketch, sketches will stretch or squash themselves, which we've seen a little bit in the past. As you add a dimension in and you set what you want that dimension to be, the sketch will modify itself or stretch or squash to accommodate that dimension that you've just entered. And the problem is with this sketch, it's of a complexity level whereby when it stretches and squashes, it can self-intersect. So let's say this corner here that I'm pointing at ends up down here. And then you've got a sketch which makes no sense. It's not a closed boundary. If anything, it's nearer to sort of a figure of 8 shape where it crosses itself in the center. So that's one of the problems when you're creating these sketches and you put too much complexity into a single sketch. They become very hard to control, and by extension they become very easy to ruin by making changes to the dimensions later on. So if you came in and said, well, I want to change one of these dimensions, let's say this 35, it seems obvious, but if I was to reduce that down below 25, these little shelves here, so this feature, would end up inverted and it would cut into the part. So yeah, we're going to do it this way, but we're going to be mindful of the fact that we probably don't want to sketch this entirely freehand first before we start dimensioning. So what we're going to do is we're going to put a handful of lines in, and then we're going to quit out of the line tool and put dimensions on those lines, and then we're going to get the line tool back again and do a handful more lines and then put some dimensions on them. So we're going to keep going backwards and forwards between Smart Dimension and Line Tool, and we're going to build the sketch up piece by piece, and hopefully that's going to be a better way to do this. The other thing to note, just before we get going, is this screenshot, the person that's taking it, which wasn't myself, hasn't taken it with the relation icon switched on. So there's a little bit of guesswork here. We can see the dimensions that are used to define this, but none of the relations are visible here. So we're going to have to use a little bit of sort of detective work to try and figure out what relations we want to put in to fully define it. So what I'm going to do, I'm going to keep that off screen to begin with, and then at some point I'll probably bring it back on and stick it on the screen so we can have it as a permanent reference. So I'm just getting that scaled correctly off screen. If you want to create a new part, that would probably be useful. So new part, yep, we'll have a new part, please. We're going to create a revolve boss base. So I'm going to select revolve boss base. I've sort of already made the decision that the side view, or the sketch, is looking at the part from the side. So I'm going to pick the right plane. So I don't regard this as we're looking at the front of the part. I would say the front is the flat circular face of the pulley. That is the front. So we're looking at it from the side. So right plane is where we're going to sketch. I'm now going to bring this back onto the screen and just attempt to pin it there so it doesn't disappear. Has that worked? Yes, it has. So I'm going to try and sketch over on the left here, have my reference pinned over on the right. And then what am I going to do first? Well, first thing, every time you create a new revolve, put the center line in. Get into the habit maybe of putting it in as the first feature. And you can see the center line on our reference is locked to the origin at its left-hand extent. So that's what I'm going to do. The center line is a sub sort of category of the line tool. So click on that little arrow, get the center line, make sure one end of its extent locks onto the origin point there. Drag the line out to the side, make sure I lock it to horizontal like that, and then click. And then I don't need that tool anymore, so press the escape key, and then I'm going to start sketching. So I'm going to get my line tool. So looking at my reference material here, you can see this diameter is 25. So what I may do is just put an initial vertical line in there that I will delete later on, that's around about half of that value, just so that when I start this horizontal line here, it's in approximately the right position vertically. So I'm going to try and aim for around about half of 25. So I'm going to lock one end of my first line onto the origin. I'm going to go up till I get around about half 25. Yep, that'll do. And then I'm going to click. And now I know this horizontal line that I'm about to begin is approximately in the right position. And then I'm going to sketch that line. So I'm going to go all the way along here. I'm going to take note of how long it is in my reference material. It's around about 60 millimeters. So I'll try and get that approximately the right length. And then the rest of them I'm just going to kind of do by looking at them and seeing if they look about the right sort of scale. So maybe there, and then there, and then there, and then there. And then I'm going to stop. So this is my first round of dimensioning that I'm about to do now. So I'm going to press escape because I don't want the line tool now. So I'm going to put some dimensions on whatever I can, and then go back in and put some more lines in, and then maybe put some more dimensions on that before finishing this sketch off. So Smart Dimension tool. We get to practice our diameter dimensions again, because we did cover this the other week, but it can take a few attempts to get it sort of embedded as knowledge. So yeah, we want to create diameter dimensions. We don't want to dimension the radius. All rotational parts like this tend to be dimensioned with respect to the diameters. You tend not to get radius dimensions on parts such as this. And when I say parts such as this, I mean fully rotational parts, parts which rotate through 360 degrees and come back to meet themselves. So undoubtedly the manufacturing process that makes these sorts of parts is something like a lathe, let's say. You tend to refer to the engineering drawings talking about diameter. You tend not to refer to them talking about radiuses. So it's good that we create our sketch using diameters. And the way that you do that is you've got to click on the center line first. Then you click on the edge or the point that you want a dimension to. So click again. And then if you drop the dimension here between the center line and the edge, you get the radius, which is not what we want. You've got to drag the dimension back over the center line like that. So yeah, we did this the other week, but even in the other session earlier this week, I was sort of asked by people, could I not just dimension everything as a radius? And I said, I've just given them the answer that I've given you. You could, but you'll be out of step with the rest of the sort of engineering world. They tend to use diameters when it's rotational parts such as this. So it's good to get this skill practiced and get it in your head. So yeah, there's my first diameter. Drop the diameter over the center line so it becomes a diameter rather than a radius. Put the value in, so that one's 25, and then keep going. Do another one. Center line, edge, drag it back over the center line, place it, 40. So that one's 40. And then that final one is, so these two ledgers. So this is our first bit of detective work. You can see that this 80mm diameter here has been applied to that ledge, that little step there. And then there isn't one on this one. So I can make an assumption that these two are actually in line with each other. So those are the same. So I'm going to dimension up this back one as 80mm. And then when I create the other one, I'll make sure that I put a horizontal relation between the two so that they always stay aligned with each other. So center line again with my smart dimension tool up to that edge, click on the edge, put my dimension where it seems sensible over here. I wouldn't put it over the top of an existing one or inside some geometry. You just want to put them where they're most clearly visible. So over there's pretty good. Drop the dimension and it's going to be 80 for that one. Then I'm going to put as many of the horizontal ones in as I can. So I could put one between the plane itself. So this is a good little aside. So I still had the center line selected there. And when I clicked on this vertical plane, the Smart Dimension tool did its thing, and it's smart. It adapts to what you click on. So it's changed from a linear dimension to an angle. It's saying, would you like to dimension where the center line is relative to that plane? And I wouldn't like to do that. So I'm going to hit escape and it gets me back out. And then I've still got some sort of dimension selected here. So I'm going to press escape again. Now I'm back to, I've got nothing selected, but I've still got the Smart Dimension tool active. So I'm ready to do my next dimension. I think what I'll do is I'll just click on this bottom edge here and I'll put a length value in for that one. So 60mm overall. So that would be that dimension there. And if I wanted to place it up the top, I could do, just to make my sketch appear like the one over here. And then is there anything else that we can add at the moment? I don't think there is, because all these other sort of steps and everything are all dimensioned with reference to their counterpart at the other side. So you can see that there's kind of a line of symmetry down here to a certain degree, but then this little bit here breaks that symmetry. But in terms of everything else, it's all symmetrical about a sort of central point. So I can't really dimension the horizontal position of these without creating their counterparts on the other side. So I've done all the dimensioning that I can do. So I'll hit escape to get out of the dimension tool. And then what I'll do, I think I'll try a slightly different approach to finishing this sketch than I have done in my other sessions. So what I have done in the other sessions, and myself and other people have managed to get themselves into problems, is I've just simply got the line tool and continued on along my path, not dimensioning, dropping lines. So I make that V shape, I go along the bottom, up the other side of the V shape, along, down, blah, 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 blah. I would suspect that it's easier to come up from this side of my sketch up towards what I've already sketched here, and then put the V shape in as the final step. So I'm going to do it that way. So what I'm going to do, I'm going to put a line in there, and then I'm going to go up vertically, and I'm going to go up till I become level with that step. And you can see here, the system has sort of registered that I've got level there with another piece of geometry. It's not offering to put any sort of relation in there to lock this point horizontal to that other one, but it has clocked that I happen to be at the same level. That's just kind of for my reference, that. So that's quite useful. So I'm going to click there. Then I'm going to come in slightly because I'm creating a little step. And then I'm going to go up a little bit, up to about there, and click again, and then along, and then maybe I'll put half of that V shape in, something like that. And then I'll press escape, and I'll start putting some more dimensions on this thing, hopefully. So, having said that, I'll just get the line tool momentarily and put that vertical in as well, like that. So, again, I'm flicking backwards and forwards. It's a good one to illustrate the point. You don't have to do your entire sketch in one go and then dimension it. You don't have to be that linear. You can, as the need befits it, you can do a little bit of dimension work and then a little bit of sketching and backwards and forwards. So in that sense, it's a good example. So I'll put some horizontal dimensions in. Smart dimension, I now have an upright there, and I have its counterpart there. So I can put that one in. Now, I'm going to drop it there temporarily. So this is the sides of the V, so this is the 25mm one. So it's going to drag one side in to try and satisfy that. I'm going to rearrange my dimensions a little bit so they make a little bit more sense. And then I'm going to put this one in, so from that vertical across to its partner over there, that one will be 35, and this might break the sketch when I put this one in. No, so thankfully it didn't. And then have we got any others? So I could put a diameter dimension up to the top of the V shape there. So let's put that one in. So that would be a center line click again, up to that edge, or up to that point if you like, and then drop that one in. And that one is the major one, so that's the 140 up to the top. You can now see that something's happened there that sort of illustrates one of the pitfalls here, which is that there must be, looking at our reference material, a horizontal relation between these two tops of these two highest points of the part. So I can kind of add that relation in now. It would be a good point to lock them in position. So I don't want the smart dimension tool because I'm going to add a relation. I'm not adding a dimension now. So I've hit escape. What I'm going to do is I'm going to pick a point, either that point there or that point there. I think I'll pick that one. That point there. Hold down Control and pick that point there as well. And then of the options that it gives me, it's that one, the horizontal relation that I want to apply to them. So they'll always stay horizontal to each other. And you can see it's added that in. If I hover over the relation icon, it's highlighting those 2 points on the ends of those lines. So that's exactly what I want. Are these two aligned? Again, you can drag these sketches around to try and figure out how they're underdefined still. So you can see I'm dragging that edge up and down. That edge should be aligned with that edge there. So we'll use a slightly different type of relation because we're kind of learning what all the different relations mean. So what I'll do is I'll click on the entirety of one of these edges rather than a point on the end. So like that. Make sure you don't click on the dead center because that will pick the center point of the edge like we used in that other example. So click sort of in one of the quarters of the edge. So there, let's say. Get that edge selected, hold down Control, do the same with this edge, so the entirety of the edge. And then of these options, it's not really horizontal because in this sense, that would apply to the edge itself. And these edges have already been locked to horizontal. You can see individually, each edge is being held at horizontal. So that's not what we want. It's that option there. Make collinear, which basically means they occupy the same sort of level, if you like, collinear in this instance. So there you go. They've been locked to be collinear with each other. If we want to test that, if we just hit escape to deselect them, and then we can grab one of them and have a go at moving it around, and it won't move vertically now. And the reason it won't move, if I zoom out a little bit, is because I've already put that 80mm diameter onto one of them, so the other one is now being also held at 80mm. But they are free to move left and right, and that's because we haven't quite finished our sketch yet. So let's continue with the line tool. Is there anything else I can do at this point? No, I don't think there is. So let's get the line tool again, and we'll quickly try and sketch in this V shape, roughly, like that. So the chances are I didn't get that quite equal when I was sketching it, but that's okay. We're about to dimension it up and add some relations in. I think I'll hit escape to get out of the line tool, and then the first thing I'll do is I'll say to the system, that diagonal line, and hold Control, and that diagonal line, I'd like them both equal in length. So I'm going to put an equal relation on the length of both of those. Excuse me. So there it is. It's a little equal sign that means equal relation. You could see when I applied that there, it sort of pushed the V slightly to the left to equalize it. So now if I try and go in and drag this around, you can see the angles of both those edges are remaining equal to each other as well as the length. Because if the lengths are set to be equal, then the angles of them must also be equal. And you can also see temporarily there when I dragged it, some of the things that can happen as you're putting your dimensions on are things such as that. So I was using another CAD system earlier in the week and teaching that and using this as an example. And that is the sort of situation that we got into where people were dimensioning up something like that or something like that, and they couldn't get the sketch back to as it should be. We ended up having to trim away the ends of these lines to try and correct it. So that's why we're kind of doing it today very tentatively and very sort of slowly and methodically, and going between creating bits of the sketch and then adding dimensions and then creating a little bit more and adding a dimension. It's just to avoid those sorts of pitfalls. So let's add some more dimensions in now. Smart Dimension tool. This edge is 5mm long. That's an easy one. Make that 5mm. And then we're getting close now. We'll put the angle one in. So if you pick both of the diagonal edges, it will tell you the angle between them. And hopefully this won't ruin it. When I put the 38 in, yep, it adapted to that. It didn't sort of ruin any other part of it. So we got the 25, we got the 35, we got the 60. What am I missing here? So we've got 100 in there somewhere. So it's 100 to the bottom of the V in terms of diameter. So click on the center line, click on the bottom of the V, set the diameter of that to 100. So we've got that one. We put the 80 in already, so I'm just ticking these off in my head. 25 and 40. I think we've got all the diameters. We've got the 5mm, we've got the 38 degrees, we've got the 25, the 35, the 60. So we put everything in terms of the dimensions now. So I'm going to hit the dimension, hit escape to get out of the dimension tool. You might have to press it a few times to get out of there. So that we can now assume there's some extra relations in here holding everything in position. because we've added as many dimensions as we've been shown, and it's still underdefined. So at this point, it may be good to, any point or any edge that's still blue, do a little bit of investigating. Click on it, hold, and try and drag it out of position. So you get a sense of how the sketch is still underdefined. So again, I said this the other week, I believe, but it's not always immediately obvious why a sketch is still underdefined. So it's good to just drag it around. And if you drag it totally out of position and you can't get it back, just press the undo key at the top. That little blue arrow that's sort of going backwards next to the print icon, it's undo, and it'll take you back to where you were. So the first thing that I'm noting is that shelf there and that shelf there should be equal in length. So I can add an equal dimension in. And in this instance, I'll use the add relations options down at the bottom left, just to show you that that's also available. If your quick access menu disappears, you can add it over here, equal. So they've been locked to equal length. So they've now turned black, but the V, its position horizontally, is still up for debate. So I think what I'll do is I'll put an equal length relation between the top edges of the V there. So that one and that one also need to be held to equal. And then we should now have a fully defined sketch. I'll get rid of that PDF. It appears as if we have. It's telling us that we have. We've got a closed boundary. So yeah, initially this looked like a sort of quite a simple revolve, that we've done revolves before. Maybe it wasn't worth doing, but in actual fact, getting that sketch sort of tied down and fully defined is quite a lengthy sort of process. And you're benefiting from my sort of experience with this over the week, which certainly my first attempt, I ended up having to delete quite a lot of the sketch and go back and do it again a couple of times. So yeah. What else to note there? Another thing to note, which again I'm sure we covered the other week. So the end of this center line is still underdefined. You can see the end point is still glowing blue. The system's willing to overlook that. Because the center line itself is just a special form of construction line, it doesn't really hold it to the same sort of rules and rigor that it holds the actual solid geometry to. The solid geometry must be fully defined before it'll give you that little readout there, but the center line, not so much. And the reason for that is essentially the center line isn't classed as a part of a sketch as such. It's just a theoretical, infinitely long axis around which your geometry can be spun. So it doesn't really care. But if I was really fastidious and I wanted to dimension everything in my sketch, I could put a dimension on that. There's nothing to stop me from doing that. But you tend to just leave it at the length that is convenient for you in terms of being able to click on it easily when you're placing dimensions. But yeah, you can dimension it if you want. So we'll click on OK to exit the sketch. Hopefully we'll get a preview that will work. Ooh, I've done something here, and I did this before. While I was talking, I forgot to delete that initial line. So if you remember, I put that initial line in just to give me the rough position of my first horizontal line in my sketch that I made. So that line there is breaking my sketch. The system's saying, you've put a line in there that isn't a part of the closed boundary. What's going on? So it's unwilling to create an extrusion for me. So I think what I'll do, I want to go back in and correct that. And really, the only way that I'm going to be able to do that is to delete the extrude. So that deleting the extrude does not mean you'll delete the sketch. The sketch will still exist, but I've got to delete the extrude because it won't accept that. So I'm going to click on cancel. There. So now what I've got, so I'm in kind of a unique position in terms of where we've been before. I've just got a sketch hanging about in the feature manager there on its own. And the system's actually dropped me back into the sketch. So you can see I'm I'm in the sketch, I can add lines in there if I need to. So sometimes it kicks you all the way out and it exits the sketch like that. And the sketch is just kind of a feature in the feature manager. It's sat there, it's visible, it's colored in gray. I'm not editing it anymore. You can see I can try and sketch, but it won't let me because I'm not editing anything anymore. So again, basic concepts of SolidWorks. People often get into this situation and then they go, well, why am I not back in that sketch? It's because you're not editing it. When you're editing it, the lines will either be colored in blue initially or in black if they've been fully defined. So when they're gray, you're not editing it. If I want to edit it, click on it there, go to edit sketch. Now I'm back into Sketcher. Now I'm editing this sketch. So you can tell some of the lines are black. I can see all the dimensions. What this line's blue that I just put in a second ago. So now I can make edits. So I'll correct that problem that I had. I'll delete this line that I've just inserted by clicking on the line and pressing the delete key. I'll zoom in a bit, click on that line, and then press delete again. So now I think I'm good to go. So I'll try this. I'll OK the sketch. It won't drop me back into the extrude because I deleted that extrude. But what I can do now is if I click on the sketch first, so I'm pre-selecting the sketch that I want to create my revolve. Sorry, I kept saying extrude there and I should have been saying revolve. So click on the sketch first just to select it. I don't want to edit it. Go into features, click on revolve, so revolve boss base. And because I've pre-selected the sketch, the system says that sketch is suitable. I'm happy to use it. Here's your preview of your revolve. So you can do it either way. If you have a pre-existing sketch, you can pre-select it and then initiate your feature. And if the sketch is suitable, the system will accept it as an input. And if it's not, it will give you an error again. But yeah, that's a different method of working if you already happen to have created a sketch in isolation, not as part of a feature. But anyway, so we're getting our preview. Preview looks good. We can still see our sketch sandwiched in there. If we wanted to play around with some of these revolve options, we could. So very similar to the extrude options, we have a blind value currently, but rather than in millimeters, it's going in terms of degrees round the center axis. Let's say we didn't want a full revolve. Let's change that to 100, and you get that sort of thing going on. So that might be useful if you're designing certain parts. Again, we have a direction option. If we click on reverse direction, a bit like the extrude, you can send the revolve off in clockwise or anti-clockwise away from the sketch. And again, there's a mid-plane option in here as well, which is quite nice sometimes. So you sandwich the sketch and the sketch plane in the center there, and it takes this value, which is now degrees, and it goes half of that value in one direction and half in the other. So yeah, similar to the extrude options that we were looking at. But in this case, we just want blind. The direction doesn't really matter because we're going to go a full rotation. So we're going to go 360 like that because this is a full pulley, and then we're going to OK that like that. So that's what we end up with. And so that's a perfectly valid way of setting this part up. And we saw that the management and creation of that sketch initially was a little bit tricky, and there were some pitfalls that you could fall into potentially. And if we went to go and modify this, so say we were in a design department and we got the call that said, oh, our pulleys, can we modify some of the dimensions of them slightly? We got a special order. Can we shrink a part of them or expand a part of them? There are certain scenarios where the sketch is going to collapse. So there you go. I've made the sketch collapse in on itself. So you've got to be a little bit aware of that as you're doing work on such a complicated sketch, that there are certain combinations of values in this sketch that will cause this profile to not work anymore. So yeah, it's tricky to set the sketch up. It's easy to break the sketch through ill thought out changes in the future. So those are some of the downsides of creating it as a single feature and a single sketch. So one of the major upsides is you can kind of see the full definition of the part from one single item, which is the sketch. So that can be quite advantageous. As long as you're careful in the edits that you make to it, the changes to the values that you make, it is quite a powerful way of setting up one of these sorts of features, a revolved feature. So that's the advantage. But the alternative to setting it up this way is to set this part up as multiple features, which is equally valid. So I'll quickly show you that. You can follow along, or it's not really necessary. It's just to show you by example the alternative to doing it this way. So what I'm going to do, I'm going to delete the revolve feature, but I'm going to keep the sketch. So click on the revolve, press the delete key, answer yes, and the revolve disappears, but the sketch is retained. So the reason I've retained that is so that my 3 sketches, or possibly 4 sketches that I'm about to create, can be quickly just locked onto this sketch. So if I was doing this for real, I wouldn't do it this way. It's just to speed the process up as we're doing it now. So what am I going to do? I'm going to create an initial revolve. I'm going to sketch on this plane, and then I'm just going to create a rectangular shape. And as I say, if I was doing this correctly, I would be putting all the dimensions in for this rectangle. But as it is, just to speed things up, I'm just going to lock it onto this sketch that's in the background because I happen to have that. So yeah, created a rectangle. I'm going to put a center line in because it's a revolve that I'm making. So there's my center line put in. Okay, that. And then I get my first feature. So there's my first feature. And hopefully you can see already, I'm building up this part feature by feature. And one of the reasons I'm doing this is because if you do it this way, things are sort of, let's say, a little bit more robust. You can make changes without doing quite as much damage some of the time. So revolve again. I want to sketch on that plane. I want to look at it normal too. I'm going to create a second rectangle. And again, I would be putting dimensions in normally, but I'm just doing this process as quick as I possibly can. So I'm just locking it onto this sketch that's in the background. I might put this center line out in that direction just so that I can see it a little bit easier. Okay, that feature. Yep, that looks good to me. One final feature, or maybe I'd do this as 2 features. Let's do it as 2. So revolve boss base. On that plane, I'll do a third rectangle, please, and then put a center line in. Like that. Okay, that one. Yep, that's fine. So I start with something like that. And then I'll cut out the material. So I'll do the V as a single feature on its own. I dropped into a sketch there and I shouldn't have. I should have done a revolve again. And I shouldn't have done a revolve boss base. This is the difficulty of speaking and trying to do it at the same time. So it's a revolve cut this time. So click on there, view it normal too, get the line tool out. And again, I would be dimensioning all these things, but at the moment, I'm just going to use that background sketch as a reference. And then put a center line in again. Center line again. And there we go. Revolve, cut. And we've cut it away. So that is an equally valid way of making the exact same part. And as I say, there are advantages and disadvantages to both. The sort of disadvantage, or the major disadvantage to doing it the second way, is that if I was to click on a single piece of this, or if I was to click on a single piece like that, I only kind of get to see the dimensions that govern just that little piece. So had I set these sketches up using dimensions rather than sticking them or relating them back to the original sketch, I would only really be looking at the dimensions that represent the V shape there. And likewise, if I was to go in and look at maybe that first feature that I created down here, that like initial shaft, I would only be able to view the dimensions that were specific to that shaft section. So that would be a big disadvantage. There would be no one sketch where I could go in and just view everything about this. But the kind of upshot is that this method it's kind of more resistant to being changed in the future, or it's more robust in terms of change. But at this point, at this level that you're learning SolidWorks at, I would not mark either method down. It's just so that you're aware there are multiple paths to get to the same geometry. So you can set things up as multiple features and try and put some logic in terms of, I class that V shape as a feature. I also class this major shaft down here as a feature. And try and break things up logically. Or, if you feel confident enough, you can go for it and enclose them all in a single feature. The choice is yours. And as I say, I wouldn't be overly critical at this point if I was marking anything from you if you chose either one of these methods. It's just to make you aware that they're both available. So, in terms of the bit that you followed through with me, the first method, again, could everyone follow the first method? Did they get their sketches working, and did you get a revolved feature out of it, the first method? I mean, how many people have we got left now? Right, I think there's 6 of us, or 7 including me. I think we got a yes then. Anyway, let's just... will we get a chance to do the final one? We probably won't now. So there was one final example here, which I'll just have a brief talk about, or maybe I'll do it as an example. You can watch this one if you want. So this is making a sphere, which hopefully you should be able to reason out with the skills that I've given you, how you might make a revolve that results in a sphere. But there's a little step that often trips people up. So I'll quickly cover it. And as I say, you don't have to follow this one. You can just view it, because I'm aware that we've only got about 5 minutes. So, revolve boss base, pick a plane. Let's pick the top plane just because we've not used it in any of the examples. Initially, we'll draw a circle like that. So it's a center point circle locked on the origin. Then I'll probably dimension it. Let's just dimension it at 100 mil, just for simplicity. Then what I'm going to do is I'm going to put a solid line in. So solid line tool, and I want to go from the top of my circle all the way down to the bottom of my circle. And then I don't want that tool. Then I'm going to make the planes invisible, because they're sort of messing up my ability to see what I'm drawing. So I'm going to temporarily hide the planes. And then what I'm going to say is, in order to create this revolve, I don't need a sketch of a whole circle. I need a sketch of half a circle, so a semicircle. So I want to get rid of this half. And there's a really nice tool that does that I don't think we've used before. And it's this scissors icon at the top, trim entities. And within there, you've got various different types of trim. The power trim is the one that is the really useful one. And what that allows you to do, so I'm going to illustrate it over here to the left, is when you click and drag, it's just a freehand line that follows your pointer around. And watch what happens. So when you let go, it disappears, and then you can do it again. So watch what happens when I drag through this side of the circle. It disappears. And the rule that it applies to making that trim is that it trims whatever it hits, but it only trims it back to its nearest neighbor. So the nearest neighbor of the circle was this straight line. So it only trims it back till it meets its nearest neighbor, and then it stops trimming. So that's how that works. So I don't need the trim tool anymore. Hit escape. One last thing before we make the revolve, just put a center line in. So center line, lock it to the origin, extend a little bit beyond this circle so it's obvious that I've got a center line, press escape, and that's it, done. Click on OK, and you get your sphere revolved. So the thing to note there, thing that trips a lot of people up is why don't I draw a full circle and just rotate it by 180 degrees? The simple answer is the system won't accept that. You always draw what's known as the half section. So whenever you do these revolves, you don't draw a full cross section, you just draw the half section. And again, that applies to the pulley, it applies to any revolve that you create. You only draw the half section, you don't draw the full section. And if I use this section view tool up here, I can prove that to you. So that's the full section. When you section through a sphere or chop it in half, that's what you're looking at, a full circle. But whenever you create the revolve, you only create the half section like that. So yeah, I think we'll leave it there, and then we'll come back in next week and we'll do some more worked examples. We'll tackle some more tools. We may even get on to producing some simple engineering drawings as well. So yeah, unless anyone's got anything really pressing now, I think I'll sign off, and I'll see you here next week again. I'll just give people a sec, just in case they're furiously typing something. Yep, I think we're all good to sign out. Right, okay then. I'll see everyone next week. And I'll upload one of these sessions, one of the 4 that I've given this week, to all the various groups. I'll probably upload one of those onto the site for at least that person that had to go a little bit early. Okay then, bye.